Good day, ladies and gentlemen. I welcome you back to Scatter Physics. Yes, we are moving forward. We are still on dimension continuation. So we have number 6 question. Please do well to like, follow, and share. Invite your friends. So let's dive to what we have. At what respective value of ABC would the unit of y-modulus and pressure be dimensionally equivalent to m raised to power a, l raised to power b, and the t raised to power c? So this is similar like what we solved in our number 4 question. So but let's see what we have on this one. So we have the options, which is A to E, which I don't even know the answer. So let's solve this first so that we can be able to know which one is the answer. So we'll go straight to our solution. We have two physical quantities, which are y-modulus and pressure. So first of all, we'll look for what? y-modulus. y-modulus. The formula for y-modulus is the what? Stress over strain. Then we have the stress is equal to what? Force over area. While strain is equal to what? Change in length over what? Change over what? Original length. So if we look here now, we see that stress is what? Is under pressure, because the formula for pressure is force over area. But if you look at strain, strain is dimensionless. Upon all the dimension that we have, we don't have anything like changing length over original length. So strain is what? Dimensionless. So let's find stress. That's what we are going to look for. So strain is dimensionless, so we don't have any business with what? Strain. So we go straight to what? Stress. So we have that force. Formula for force is ma, mass times what? Acceleration. Stress was mass times acceleration. All over area is length times breadth. So we go again. Mass times formula for acceleration is velocity over what? Over time. All over length times breadth equals to again mass times formula for velocity is what? Distance over time. Over time. All over this time that we have. Length times breadth. So now, if you look at this now, you see that mass does not have any formula. This time, no formula. So everything has been under what? The three physical quantities, which is what? Length, mass, and time. So we apply it. Mass is for m. Distance is L, because it's talking about what? Length. Time is T. Length L. Breadth still L. So we have equals to m times LT. Removing the division sign is equals to what? Raised to power minus. So we have minus 1. Then T again, minus 1. Then times this L times L is going to give us what? L square. So if we remove the division sign, it's going to give us what? Sorry, L times L is going to give us what? L raised to power 2. So removing this division sign, so it's going to give us minus. So now we have L minus 2 raised to power. So now, since we have gotten this, we collect like terms, which is, we have 1 here, like what I told you earlier before, invisible 1. So 1 minus, we have m, then 1, this L raised to power 1 minus L raised to power minus 2. So we have L minus 1. Then minus 2 on T, minus 1 is going to give us what? T raised to power minus 2. So our stress equals to T m L raised to power minus 1, then T raised to power what? Minus 2. So now we will not go into solving for what? Pressure, because pressure says that force over area. That's what pressure says. And you see that we started from what? Force. Just by say we are talking about stress. So pressure and the stress, they are what? They are equivalent. So that's why we will not go and start looking for what? For pressure. So we have pressure also. Dimension is m L raised to power 1 T raised to power minus 2. So this is what we have for what? For pressure and stress. So now, at what respective value of A, B, C would the unit of y-modulus and pressure be dimensional equivalent to M, A, L, B, T, C? So we have that the dimension of pressure and stress to be what? M, L, okay, this M is raised to power what? Minus 1. L minus, M is raised to power 1. Then L is raised to power what? Minus 1. Then T minus 2 equals to MA equals to M L minus 1 T minus 2. So remember that what we say that anything raised to power 1, that's why we have this. Anything raised to power 1 is what? Is the number. Like m raised to power 1 is what? M. That's why we say that this m raised to power 1, t raised to power minus 2, and t raised to power minus 2 is equal to what? M L raised to power minus 1 and t raised to power minus 2. Then, going to what we have on the board now, we say that this m raised to the power A, L raised to the power B, and T raised to the power C is equal to what? M raised to the power 1, L raised to the power minus 1, T raised to the power minus 2. So now, applying indices, so we equate so we have using indices method. So we have that M raised to the power A is equal to what? M raised to the power minus 1. L raised to the power B is equal to what? L raised to the power minus 1. T raised to the power C is equal to T raised to the power what? Minus 2. So when we talk about indices, we talk about power, raised to power, raised to power, raised to power. That's what, when we talk about indices, we talk about raised to power. So now, indices of this is going to give us A equals to 1. Indices of this is going to give us B equals to minus 1. Indices of this is going to give us C equals to minus 2. So we have 1 minus 1 minus 2. So let's see what the answer is. The first one, minus 2 minus 1, 1. No. Second one, 1 minus 1 minus 2. Yes. So the answer is what? B. So thank you for giving it time, and thank you for watching, and thank you for listening. Please like, share. In fact, make sure you like each of these our videos. This is Scatter Physics, your #1 solution in physics calculation. Please invite and share to your friends so that we learn and grow together. Thank you very much for watching. See you next time.